Hi everyone, welcome back to my channel. You are watching Education to All. So this is Vinod Kumar. Today we are going to start about a topic named polynomials. So NCRT polynomials topic. The polynomial we can segregate with the two different names, that is poly and the nomials. Poly means many, nomials means terms. So together we say that many terms. The discussion about many terms is nothing but discussion about the polynomials. So in this topic, what we are going to learn, so I'll show you. We have to learn the introduction of the polynomials, the geometrical meaning of the zeros and the polynomial, the relationship between zeros and the coefficient of a polynomial, division algorithm for the polynomial. So let's start with the introduction. What is the definition? An algebra expression is an expression built of form, constants, variables, and the algebraic operations such as addition, subtraction, multiplication, and division. So this you might know. Again, I'll repeat. The algebraic expression contains constants, variables. So what is meant by constants and variables? So let me explain clearly. Constants. The name itself suggesting it's a constant, no? So we can say a fixed value. All fixed values are comes under constants. So what are the fixed values? So value is simply say that numbers now. So we can say that all numbers are examples. All numbers. What are the numbers we have? So examples are like natural numbers, whole numbers, integers. So all real numbers I can say. So let us write an example. So like 2 is a constant, 3 is also constant, so 0 is also constant, minus 3 is also constant, root 2 is also constant. So these are the examples I can say. So all numbers are the constants. Next one we should know variable. What is meant by variable? So variable is simply say that it's a varies. So we can say which is varying now a symbol. So is a symbol which is used to represent. Which is used to represent unknown conditions. A symbol which is used to represent unknown conditions or unknown situations. What are the examples? Suppose we have to consider a cost of an item or cost of a pen. Simply, if you are not known, we consider that let x is the cost. We say no. So x is a variable we can say in this situation. So examples are all alphabet like A, B, C, and so on, X, Y, Z. So these all comes under the variables. Got it? And the next one should learn term. What is meant by term? The combination of the variables and constants. So in other words, we say a constant alone or a variable alone are both combination together. For example, 2 is a term, x is also a single term, but when you combine these both like 2x, 2x is also a term. Now observe carefully, 2 is individually it is a constant, only number, x is individually only variable, but 2x contain constant, contain variable, but it is also comes under the term only. When you use mathematical symbols such as plus and minus, it will differentiate the counting of the terms. Like 2 is a single term, x is a single term. When you add plus here, otherwise 2 minus x, or sometimes x minus 2 also. Now the plus symbol, you observe this plus symbol differentiate the number of terms. This is called single term and it is also become a single term. So this becomes two terms. How many? Two terms. If the one more plus any number if I write in, it will be one more term it will be. Okay. It depends on the number of plus symbols are there and minus symbols are there, and it having any differentiate for that you have to get. And in this terms, we should know somewhat clarity. The clarity is, I'll write this. So the new word like terms, and the second one is unlike terms. The second one is unlike. What is meant by like terms? What is meant by unlike terms? So terms means we are clear, and like terms means a variable is same with the same exponent with the different coefficients. Let us take x is a term and 2x is also a term. Now variable wise and exponential wise both are same. So these both called as like terms. So same symbol with the same exponents. I say that same symbol with the same exponent. Can I say that x square with the minus 3x square is also say like terms? Definitely these both also like terms. But when I see this x square and x, can I say this is like terms now? Variable wise it is same, but exponential wise it is not same. So that's why it is not a like term. So what it is called? So this is second segregation. So this is will comes under the unlike terms. So what is meant by unlike terms? A variables which have different variables are same variable with a different exponent. So same variable with different exponent are different variables. Example, x is a variable, x square is also a variable, which terms these both are same variables but different exponents. So this will be comes under unlike terms. So we can also write with the different variables. Let us say x and y. So these both also not having the same variables. So these both also called unlike terms. So why we should learn about like terms and unlike terms? What is importance in these both? Like terms can be added. So we can add the like terms. Add. What is meant by addition of like terms? So x square plus 3x square is there. Can I simplify this? Definitely the coefficient should be added. So this before one is called coefficient. This before one is also called coefficient. 1 plus 3 is 4. So we can say 4x square. So can be added, and it is also can be subtracted. Subtracted in the sense like subtraction you go x minus 3x. So you get it as minus 2x. So this subtraction also possible in this multiplication. X into some x we get exponential added, no? So x square you get it, no? So this multiplication also possible. And whether division is possible or not, definitely in like terms division is also possible. X divided by x, this leads to 1. Then we can conclude that addition is possible, subtraction is possible, multiplication is also possible, and division is also possible. So remember, these all mathematical operation can be done by using the like terms. In the same scenario, whether it is possible with unlike terms, observe that x square added with x, these both are different terms. Same variable but different exponents. This cannot be simplified. So this will become same x square plus x only. So addition cannot be simplified. So addition is does not possible. Addition is not possible in a situation. And subtraction also you can get it. So x square minus x. This is also further cannot be simplified. X square minus x. And also you can observe with the different variables now x plus y. Still it will become x plus y only, and x minus y. Still it will become x minus y only. Can I multiply it? Definitely x square is multiplied by x. What happens? The simplification can be done. X power 3 will come. So we can surely say that multiplication is possible in unlike terms. Whether division is possible, which is x power 3 is divided by x square. Simplification is done, so x will get. It means that in unlike terms, what is possibility is there, multiplication is possible and the division is also possible. But what is not possible? Addition is not possible, subtraction is also not possible. I hope you understand. So come back to the definition again. An algebraic expression is an expression built up from constant variables and algebraic operations. Algebraic operations such as addition, subtraction, multiplication, and division. So these are the examples we written here. X plus 3 is one of the expression, and 3x, 3y minus 8, 7x square, 5xy plus 8z minus 3 root 3z cube, etc. So these are the examples. Next, consider the expression 5x cube minus 4xyz plus 8. In this, individually, this one is called an term, and this is also a term, and 8 is also a term. So already we discussed what are the terms and what are the types of terms. Types are like terms and unlike terms. Now, from the based on the terms only, we have to frame a definition of the polynomial. What is the definition of a polynomial? Here I attached. You can see. In general way, an expression contains one or more terms with non-zero coefficients. This is very important. Non-zero coefficients and the variable with non-negative integers as an exponent. These both are very crucial words. So again, I'll repeat the definition. An expression containing one or more terms with non-zero coefficients and non-negative integer powers as a exponents. Then it is called as a polynomial expression. I can say that x square plus 3x cube minus 3 by 4 x power minus 3 plus some 13. This is will becomes an expression. It contains the positive exponents, negative exponents also. But whereas polynomial contain what? So polynomial now the definition of polynomial I'm teaching. An expression contains non-negative exponents, non-negative exponents as well as non-fractional exponents. Non-fractional exponents. For example, it should not contain like this x power minus. So minus 3 is already there in the previous expression. It's called an expression. If it is contained in such a way, it will never be a polynomial. And for example, x square plus root x plus 3. Is this a polynomial? But it will be polynomial is called or not, we have to be clear. This is never called as a polynomial. Why? Because here root x. It's simplified now x square plus x power 1 by 2 plus 3. The definition itself saying that non-fractional exponents, non-negative exponents also, no? It contains fractional exponents, so this is not be a polynomial. Then can I say this 3 x power minus 3 is a polynomial? No, it is also not. So how the polynomial look like? So let us take p of x is a polynomial. I can write this way. Let p of x is a polynomial. We can write it as so a1 x power n plus a2 x power n minus 1 and a3 x power n minus 3 and so on at last an x power n minus n means 0. It means a constant it will come. And here where a1 comma a2 comma a3, these all are called coefficients, and n is called exponents, n comma n minus 1 comma n minus 2 and so on. These are called exponents. Now condition is if a1 is not equal to 0, it's called the degree of the expression. I'll explain what is the degree of a polynomial before going to the discussion of this one. It is called an polynomial in P of x. A1 x power n plus A2 x power n minus 1 and so on. An x power 0. X power 0 is anything power 0 you might know. It is 1. So last term is only constant. Coming back to the examples of a types of polynomials, which examples I will discuss. So based on two criteria, we can divide the polynomials. Let me explain clearly. First, the degree of the polynomial will discuss. What is meant by degree? If any polynomial contains highest power, let us example x power 9 plus 3 by 4 into x square plus 3x plus 5x power 10. If this is given data, what is the degree of the given polynomial? Whether it's a polynomial or not, first you observe that every exponent is a positive and non-fractional, so definitely it's a polynomial. And degree, which is having highest degree, you check it here, it is 9, next to here is nothing, means 1, here it is 10. So we can clearly say that degree is equal to, degree of the polynomial is equal to 10. Suppose if it is there in a variable way like ax power 10 plus bx power 9 plus cx power some 7 and so on, d. It is given a polynomial. What is the degree of this particular polynomial? So we can say directly degree is equal to 10. Am I saying like this? Is it correct now? Absolutely not. Why? Because we are not aware of the coefficient of x power 10. If suppose it may be 0, if a is equal to 0, what happens? This term will exist? No, it will eliminate it. Why now? How it will be? 0 into x power 10, it will eliminate. So plus b into x power 9 plus c into x power is 7 plus d. So this leads to b into x power 9 plus c into x power 7 plus d. Here we should aware more students, a, b, c, all these are the coefficients, not the variables. They should not be considered as variables. Okay, and that's why this is eliminated now. This is the highest power. If suppose, can I say directly this is 9 is degree? No. If b is equal to 0, then it will come to the 7. So c is also 0, it will come to the d. D means only constant. So before answering the question, if the given polynomial contains the all coefficients with the numericals or unknown coefficients is there, we should be justified. Then we have to decide that it having a degree is what. Suppose if given, if a is not equal to 0 only, if a is equal to not, a is not equal to 0 is mentioned, I can say degree is absolutely 10. That is absolutely true. Got it? And next, types of polynomials we'll discuss. Now, types. So types of polynomials, there are two segregations we can say surely. So segregations are based on terms and based on degree. First one based on, and the next one based on degree. So we discussed what are the terms is called and what is the degree also. No? So now based on terms, what are the types we have? First one is if single term is called a monomial. Example is x square is a monomial, otherwise 2 is a monomial, 3x power 9 is also a monomial. Single term alone is called a monomial. And the second one, if two terms alone, so it is called binomial. Binomial it contains two terms. So here you should realize the monomial or binomial, we should not bother about degree. So no need of getting degree is 1 or degree is 2 should be followed. It's not like that. It can be anything degree. So binomial means two terms exactly. Let us take x plus y is a binomial. Otherwise x cube minus 3 by 4 is also binomial. It will take many terms means different. Exactly two terms. Okay, two terms should be there. Next, the third one, if having exactly three terms, it's called as trinomial. In maths, we know, I think so. Mono means one, bino means two, trino means three. So nomial will attach by the polynomials. Okay. So now, trinomial it contains three different terms. Let us imagine a x plus y plus z three different terms. Otherwise x square minus 3x cube minus 7 by 4 into x power 9. This is also a trinomial. What is called if more than three terms is there? Is there any particular name? Yes, we have. If it is more than three, directly I'll say that more than three, not exactly four, not exactly five. So remember more than three terms. So it having same name, it is called multinomial. What we call multinomial. Example is anything we can write which contains minimum four terms. Example x power 4 plus 3 by 4 into x cube plus or minus. So 7x square minus x plus some 13. So it contains more than three terms. So definitely it is called what? Multinomial. If it is five terms also, six terms also, same we can call. Now based on degree. What is the possible degree is a minimum? Can I say 1? No. We can say degree 0. First type is degree 0. Degree 0. What we called? If degree is 0, how the polynomial looks? For example, x power 0. What happened? It will be 1 only. Na? What is 1 we called? Initially we discussed 1 is the constant. So we can say that if degree is 0, it's called as constant polynomial. And next, if degree is 1, degree is 1, what we called? So it's called, if degree is 1, it's called as linear polynomial. Here you should be aware of that constant polynomial difference. Can I say all numbers? If anything power 0, it will become like 1 all numbers is a constant polynomial. No. Here all numbers are constant polynomial except the number is 0. We have that number 0. 0 into x power 0. What happened? It will get 0. So 0 is especially we have separate name that is called 0 polynomial. So this is entirely different than the constant polynomial. Please make a note. So example of linear polynomial is ax plus b. And here condition we have where a is not equal to 0. If a is equal to 0, what happens? It will turn to the constant polynomial. B is only constant, no? So that's it. Next one. Third one, if degree is 2 exactly, it is called quadratic polynomial. What is meant by quadratic polynomial? Degree is 2. So we can say general example is x square plus bx plus c is called as quadratic polynomial, and where a is not equal to 0. This is must should be found. So next one. So take the fourth one. So the next one we can say degree is 3. If degree is 3, what we call? So if degree is 3, we can say that cubic polynomial. Cubic polynomial. So example we can write it as a x power 3 plus bx square plus cx plus d. And here a is not equal to 0 once again. Why it is not equal to 0? No? If this is equal to 0, the highest power is 2. So 2 means it will become a quadratic equation. Similarly, a is not equal to 0. Why? If this is 0, it will turn eliminated and it will lead to the mean. That's the purpose. Next type, so fifth one. If degree is 4 by quadratic polynomial. Example is a x power 4 plus b x cube plus cx square plus dx plus some e. And here also condition a is not equal to 0. So these are the types of the polynomial based on degree. So I said one extra is there zero polynomial. So now I'm explaining zero polynomial conditions and what are the importance of it. The first one is zero polynomial. What is meant by zero polynomial? In a polynomial number zero is alone called as zero polynomial. Why it is so? If 0 is the coefficient of x power any number, like x power 0 means answer 0. 0 into x power 1, answer is 0. 0 into x square, answer is 0. 0 into x power from 5 is also 0. Similarly, 0 into x power, let us take n, this is also 0. Now, it is very simple to understand whatever the exponent you are taking time with the coefficient of 0, answer getting still 0. Then for 0 polynomial, degree cannot be found. Say that degree cannot be found. For what polynomial? 0 polynomial. What is meant by 0 polynomial? The number 0 alone is called as 0 polynomial. So why it is so? The degree is varying time also still answer getting 0 only. So that's why we say that degree cannot be found for 0 polynomial. Is there any other polynomials if degree is 5 degrees, 4 degrees, sorry, degrees 5, 6, 7 and so on. So there is no particular name after the 4 degree. So we can say that if degree is 5, fifth degree polynomial. What we say? Fifth degree polynomial. If it is degree is n may be any number. So nth degree polynomial. These are the examples. We can write with the degree 5 or degree 6 or degree 7 also. Now, what is the importance of zero polynomial? Zero polynomial, it doesn't have any degree, means it cannot find the degree. Now, the new concept is very important. This concept is very important. Value of the polynomial. What is meant by value of the polynomial? Let us take an example. P of x is equal to x square plus 2x plus 3. What is the value of this polynomial p of x? At x is equal to 1 and x is equal to minus 1. How to find these particular value of the polynomials? Simply replace wherever x you identify with 1. So p of 1 is equal to 1 square plus 2 into 1 plus 3. So this leads to 1 square is 1 plus 2 into 1 is 2 plus 3. So answer will give us 6. So P of 1 value will be 6. Similarly, P of minus 1, what happens? Replace wherever you identify x with minus 1. Minus 1 whole square plus 2 into minus 1 plus 3. So minus 1 whole square is 1 only. 2 into minus 1 is minus 2 plus 3. So 1 plus 3 is 4. 4 minus 2 is 2. So this is the value of P of minus 1 is x is equal to minus 1. The value is this. So we can find in any type of polynomial that x is equal to something. So this is called the value of the polynomial. Based on this concept we have another one, so that is called zeros of the polynomial. What is meant by zeros of the polynomial? So this concept is very important CBSE level. Now let us take an example. P of x is equal to x square minus 4x plus some 4 plus 4. If I take this is an example, what is the zeros of this particular polynomial and what is it meant? Zero. First, zeros of the polynomial is simply say that the value of the polynomial at what values is 0. For example, p of 1 is 0. The value of the polynomial becomes 0. At what value it is 0, that is called 0 of the polynomial. So I can say that 1 is the 0 of the polynomial. Simple example we can cross-check for this example. Let us take p of 2. What happens? P of 2 means 2 square minus 4 into 2 plus 4. What will it? 4, 2 square is 4 minus 2 4s are 8 plus 4. And this leads to what? 4 plus 4 is 8 minus 8. And this further will be 0. So p of 2 value is 0. Whenever the value of the polynomial becomes 0, so at what value this answer is 0? And I can say that the value will be 0 of that particular polynomial. I hope you understand. At what value? You can observe that p of 1 is 0. Suppose you get that p of 1 is 0 for me. Example, I can say that 1 is the 0 of the particular polynomial. Then how many zeros it having for any type of polynomial? It is always depends on degree. If degree is 2, it having 2 zeros. We say that at most 2 zeros. If degree is 3, we can say that it having at most 3 zeros. If degree is n may be any value, so it having at most n zeros. Then what is that at most condition? Why it is not exactly 2 zeros, not exactly 3 zeros, not exactly n zeros? If at most 2 zeros means, you can see this example. If we take this x square minus 4x plus 4 and we'll try to solve in factorization method. So p of x is equal to x square minus 4x plus 4. So I'll take the factorization like x square. So 1 into 4 is 4 in product. So we have to get the factors for it. 2 2s are 4 and we have to add it. Why we have to add it now? 1 into 4 we get as addition. So remember, when you add, we got the product is positive, we should add, remember. When the product of the first x square coefficient and x constant, when we got the x square coefficient and constant, product is negative. So remember, we have to subtract the factors. So this is the hint to solve the zeros with factorization method. So I'll use to do minus 2 for these both. I can write x square minus 2x plus 4. From the first two times I can take x common. What is pending? X is pending, and in this x taken out, 2 is pending. Minus 2 taken out, x is pending, and this 4 minus 2 is pending. And further x minus 2 is further taken. What is pending? It having x minus 2. It is very simple to understand. From this x plus x minus 2, what is x value? So you get x is equal to 2. Means at what value this will be 0. If x is equal to 2, this will become 0. Similarly, at x is equal to 2, this is also will be 0. Now observe that p of x contains same zeros, no? But degree is 2. It having 2 zeros will come. but two zeros giving us same answer. So that's why we say that it having repeated roots. We can say that roots are equal or zeros are equal zeros. So in this situation, we can say that at most two zeros only. Why? Because the two numbers are having the repetition of the same number, not 2 comma 2 means single digit only. This way we say that it having at most two conditions. And is there any other condition? It doesn't have any roots. So for example, x square plus x plus 1 you can take. It's also one of the example. Now we will try to find the values for this particular polynomial. If I take the p of 1, what will get? 1 square plus 1 plus 1. It will get it as 3. So it is not equal to 0. So this is also not having any 0. Means the 1 is not a 0 of the particular polynomial. Similarly, we try to do with the p of minus 1. What happened? Minus 1 whole square plus minus 1 plus 1. So minus 1 square is 1 plus into minus 1 is minus 1 plus 1. So this both cancel and it leads to 1. This is also not equal to 0. But we said that if degree is 2, it should satisfy the roots is number of roots zeros is 2 no? But here this doesn't have any zeros. Plus 1 is also not satisfied, minus 1 also not satisfied. You can take the remaining examples also, it will not satisfy. So it doesn't have any real roots, we say. It doesn't have any real roots. So we say that no real zeros or real roots. That's why. So based on these examples, we can justify that it having at most two zeros or at most three zeros, at most n zeros. At most means the minimum is 0 next to 1 and 2. So at most 2 means it may contain 0 means no real roots and 1 real roots and 2 real roots. So it will be include all these three possibilities. So that's why we have to use the word at most two zeros. I hope you understand well the topic name polynomials. If you like the video, please. I hope you understand well. If you understand well, please like the video and subscribe to my channel and suggest to your friends. Thank you for watching. Have a nice day. Thank you.